Next, find the zeros of the following polynomials. So here what zeros means, first of all take here 2x minus 3, it is equal to 0. Okay, we have to find the zeros. What do you mean by zeros? I will tell you. Okay, first of all take here f of x is a polynomial, make it as f of x, it is equal to 2x minus 3. So 2x minus 3 is equal to 0. Then 2x is equal to, if you are transposing from LHS to RHS, it becomes positive. So x is equal to 3 by 2. If x is equal to 3 by 2, substitute in this equation only. If it is equal to 0, then it is a 0 of a polynomial. This x is equal to 3 by 2 is a 0 of a polynomial. Otherwise, it is not a 0 of a polynomial. Same substitute here. Okay. 2 into, what is the x value has given? 3 by 2. 3 by 2 minus 3. 2 will be cancelled. So 3 minus 3. So it is equal to 0. So whenever the variable he has given, x is equal to 3 by 2 or 1 by 2 or 1 by 2 or 1. Again, we have to substitute in this equation. If it is equal to 0, then it is a 0 of a polynomial. Otherwise, it is not a 0 of a polynomial. Then take here x plus 5. X plus 5 is equal to 0. Okay, think this as f of x. Okay, f of x is a polynomial, x plus 5 is equal to 0. Then x is equal to minus 5. Why? Because we are transposing from LHS to RHS, it becomes positive becomes negative, negative becomes positive. Therefore, x is equal to minus 5. Substitute here x equal to minus 5 in this equation only. Okay, then minus 5, here minus 5 plus 5, it is equal to 0. So the given function, what he has given, polynomial f of x is equal to x plus 5. So x is equal to, we got here x is equal to minus 5. Substitute in the same equation. If it is equal to 0, then it is a 0 of a polynomial. Otherwise, it is not a 0 of a polynomial. Next, take here. Take this question, x square minus 5x plus 6. X square minus 5x plus 6. So there are so many methods to find roots of a zeros of a polynomial. First of all, take here x square minus 5x plus 6. First of all, take here 6. 6 can be written as 3 into 2. 3 2s are 6. Okay, 3 2s are 6. Positive 6 is there. So minus 3 minus 2. Why? Because minus into minus plus. Why? Because here plus 6 is there. 3 2s are 6. This is splitting into middle terms. Prime factorization. These are the prime numbers. Okay, prime factorization method. Okay, now x square. Take here minus 3x and next to minus 2x plus 6. Sir, if you multiply, you have to get this. If you add or subtract, you have to get here middle term. Okay. Sir, if you multiply this term, you have to get here 6 plus 6. If you add or subtract, you have to get here middle term. So this is also called middle term factorization, splitting into middle term factorization. Okay, prime factorization method it is there. Okay, we call it as. Next, what is here common? X is common. X minus 3. If you open the bracket, x into x, x square. X into 3, 3x. Okay. Now in the same way, first of all, here put here x minus 3. Why? Because same term should be here also. Okay. Now, what should be common here? See here, 2 into x, 2x. 2 3s are 6. Minus into plus, minus. Minus into minus, plus. Okay. What is here common? Here x minus 3. Here also x minus 3. X minus 3. And next, here x minus 2. See here, x minus 2, x minus 3. It is equal to 0. What are the value? What we got here? If we split into middle term, x minus 3 and x minus 2, we got it. Okay. But what is the question he asked you? We have to find the zeros of a given polynomial. So x minus 3 and next x minus 2, we got it. But the given function is, if given polynomial is f of x is equal to x square minus 5x plus 6 he has given. So it is equal to 0. Given, if you want to find zeros of a polynomial means we have to substitute here x equal to x minus 3 is equal to 0. And next, here 2 terms we got it because the power is 2. If the power is 2 means we will get here 2 zeros. Next, in the above equation the power is 1. So we got here only 1 0. And next, here also the power is 1. We got here 1 0. If the power is 2, we will get 2 zeros. If the power is 3, we will get 3 zeros. Okay, so first of all take here x minus 3 is equal to 0. X minus 2 is equal to 0. X is equal to 3. Here x is equal to 2. So these are the zeros of a polynomial for the given function f of x f of x is a polynomial, x square minus 5x plus 6. First of all, substitute here x is equal to 3. f of 3. 3 square minus 5 into 3 plus 6. 3 3s are 9. 5 3s are 15. 15 plus 6. Now 6 plus 9 plus 6, 15. 15 minus 15, it is equal to 0. So at x is equal to 3, the given polynomial is 0. Again, x equal to 2, substitute here. f of 2 is equal to, in the same polynomial only. Okay, in the same polynomial. 2 square minus 5 into 2. Wherever x is there, we have to substitute here 2. In the above equation also, we substituted here 3. Okay, plus 6. 2 square is 4. Minus 5 2s are 10 plus 6. 6 plus 4, 10. 10 minus 10, it is equal to 0. Okay, so what is the degree here? The power is 2. So we will get here 2 zeros. Now page number 35. He has given linear polynomial. He has given find the zeros of a polynomial. Here x plus a. What is the answer that here? First of all, here x plus a is equal to 0. Then x is equal to minus a. So the value is minus a. Next here x minus a is equal to 0. Then x is equal to a. The given polynomial 0 of a polynomial is a. Next ax plus b is equal to 0. Then ax is equal to minus b. Then x is equal to minus b by a is a 0 of a polynomial. So what is the answer here? Minus b by a is a 0 of a polynomial. Next, ax minus b is equal to 0. Then ax is equal to b. Then x is equal to b by a. The given polynomial is ax minus b. What is the 0 of a polynomial? B by a is a given polynomial. Next question. Think and discuss. Page number 36. X square plus 1 has no zeros. Why? Why? Because first of all here x square plus 1 is equal to 0. Why? Because we have to find the zeros of a polynomial. Okay. Then x square is equal to minus 1. Here the power is 2. So we will get here one positive, one negative. If the power is 3, we will get here 3 terms, one positive and negative. Okay. Next, why? Because the power is 3, we will get here 3 zeros. If the power is 2, we will get 2 zeros. Okay, so x square is equal to plus or minus 1, we will get it. Okay, why? Because here the power is 2. So we have to get here 2 zeros, one positive one, one negative one. Substitute here positive 1 and negative 1. If it is equal to 0, it has zeros. Otherwise, it has no zeros. So let us take f of x is a given polynomial x square plus 1. F of 1 substitute here. What happens? 1 square plus 1, it is equal to 2, because 1 square is 1, 1 plus 1 2. So it is not equal to 0. Okay, again substitute here f of x in the same equation, x square minus plus 1. What is the next value? Minus 1. F of minus 1 is equal to minus 1 whole square plus 1. So minus 1 square is 1 only. Why? Because minus 1 into minus 1, it is equal to 1. Why? Because minus into minus plus 1 ones are 1. So 1 plus 1, it is equal to 2. So f of x is equal to x square plus 1 has no zeros of a given value. Zeros means we have to get here zeros, but we are not getting here 0. If you substitute here plus 1, we got here 2. If you substitute here minus 1, we got here 2 also. So it has no zeros. Next, can you tell the number of zeros of a polynomial of a degree n will have? Suppose the given polynomial x plus 1. Again take x square plus 2x plus 1. Again take x cube plus 2x square plus 3x plus 1. Suppose if you take 4x power 7 plus 5x plus 6. So the power is 1, it has 1 zeros. The power is 2, it has 2 zeros. The power is 3, it has 3 zeros. We have to check highest degree. We have to check here highest degree. Highest degree is here 3, so it has 3 zeros. The highest degree is 7, so it has 7 zeros. So it has 7 zeros. If a polynomial has nth degree, it has n zeros. If the polynomial, suppose if you take 5x power n plus 4x plus 6 is there. Here degree is n, so it has n zeros. It has n zeros. If the 7, here n is equal to 7, So it has 7 zeros. Here n is equal to 3, it has 3 zeros. Here n is equal to 2, it has 2 zeros. If n is equal to 1, it has 1 zero. Okay, right.